Okay, so here for our last type of integral sub is when we have the x squared minus a squared. All right, now a couple things here. When you do have something like this and you do have the x squared, but the other value is, it's not a perfect square, that's okay. All right, we're just gonna make our substitution be. So here our sub is gonna be, instead of, well, our a is actually root 7, not 7, right? Because a squared would be 7. All right, so we'll just let x be root 7 secant of theta, right? For this particular type, when our x squared, it's x squared minus a squared. All right, and then our secant of theta is equal to x over root 7. And then also our dx is root 7 secant theta tangent theta d theta. All right, and then just to, let's set up our triangle here. If this is theta, secant is the hypotenuse over the adjacent, which is root 7, which means the opposite is x squared minus 7. Okay, so now we're here, and let's set up our integral. Let's do our initial substitution here. All right, so when we substitute, we get the integral. So x is root 7 secant of theta times, let's do the dx is root 7 secant theta tangent theta d theta. All right, and all of that over 7 secant theta or secant squared theta minus 7. Okay, so let's continue here. So here, when I factor out the root 7, I'm going to reduce one of these, right? One of those reduces, but I still have another one here. So let me factor that out. So we get 7. And here we're going to have secant theta times secant theta tangent theta over the bottom, secant squared theta minus 1, that reduces to tangent squared, but take the root. We get tangent theta and then times d theta. All right, and then this reduces here to 1, and we're left with root 7, the integral of secant squared theta d theta. All right, so everything kind of reduced nicely to this basic integral, right? The integral of secant squared is the tangent of theta. And again, don't forget the plus c. Okay, and then from here, so last thing is to change it to x, and we would see here, tangent of theta is the opposite over the adjacent, which is root 7, and then one last reduction here, x squared minus 7 plus c. Okay, all right, now if you're sitting there and you're looking through seeing this whole video, and then from the beginning you're like, well, couldn't I do a regular u substitution? And yes, you could have, right? You could have said, since the derivative of x squared is 2x, I have the factor of x here, right? The 2 I can always divide it in, right? But again, the point here is that there's more than one way to solve these integrals, right? Here I took a different approach, right, where I used a trig sub, and I arrived at the same result, right? You would also arrive at this result if you did a u substitution to begin with versus a trig sub like it did here, right? We don't always have that available to us. That's not always the integrals don't always fall where we can do a simple u sub, but as we could see, sometimes we could do both and we get the same result.